This is a recording for Monday, April 29th for geometry, second hour. And this is the beginning of section 8.4 on trigonometry. We'll spend a couple of days, which is a little unusual, on this section to kind of get through everything because we practice some things as we go. So you should be noticing that on the board it says to write homework. That is 3 worksheets, sine, cosine, tangent, find the missing side, find the missing angle. And you'll also notice the due date is out a little bit further than usual, because we will be starting most of those worksheets in class, and you will have some class time to work on them. And then once we're all done with that, you'll be turning them in. And we will be doing the section homework, but not right away until we've done some of these other things. So this is the heading page for this section, and it is 8.4 trigonometry. The essential question: can you find trigonometric ratios and use them to find side lengths and angle measures in right triangles? Take a moment, write that, make sure you write down your level of understanding, and you've written this in the table of contents. If you need more time to write this, pause this right now, because then I'll move on to the key terms page. Okay, moving on to the key terms page. Here's the key terms page. I am just going to read this so I know how long it takes to at least read it. This is about trigonometry. We're defining that word, and it comes from the Greek words trigon, which means triangle, and metron, which means measure. And it uses relationships, it should say, with triangle measure. And so I'll add an S there, and I'll fix that slide later on. And then a trigonometric ratio is the ratio of the length of 2 sides of a right triangle. And to solve a right triangle, because that's a directive you'll get, is finding the unknown angles and side measures of a right triangle. You need to know 2 side lengths, or 1 side length and 1 acute angle measure in order to be able to solve a right triangle. We always know the right angle, so that's something to kind of be aware of. And I will help you with your calculator, but right now, if you have your scientific or graphing calculator, take a minute, and I have these on here just so that we can practice them. And take a minute and on your calculator, enter in tangent 30. Enter, see if it gives you 0.58. If it doesn't, you might need to check your mode. If it's a graphing calculator, you'll push mode, down, down, right, enter, I think is the keying sequence. If you can't get that to work out, I will help you tomorrow when I've returned. And then the second thing is, if you do the inverse tangent of 0.58, that should be about 30 degrees. And I ask that you try those on a calculator. If you can't get them to work today, just make sure that you tell me tomorrow. Also, please make sure that you're writing the tangent of 30 degrees is approximately 0.58, and that the inverse tangent, tangent to the -1, we'll talk about that again, is 0.58 is about 30 degrees. So that if you're ever unsure if your calculator is set in the right mode, you could do those problems and write in your notes, it should say what is the correct answer, so you'll know what you should be expecting. Please take a minute also and write this. It's going to be a mnemonic device, and we'll talk about that as time goes on too. And we will practice that in class. Today, you're just writing it down, SOHCAHTOA. And we'll talk about kind of what that means as time goes on. If you need to finish writing these terms, then by all means pause this and then move on when you're ready. I'm going to move to the next slide. So again, pause this, or here we go. There's some things that I think are important. So I have this study slide for us to look at. And if we remember this mnemonic device, SOHCAHTOA is the way that we'll say that. SOHCAHTOA, it can help you remember the trigonometric ratios. And a lot of times we write it right at the top of our paper as we're starting a worksheet or a homework or whatever. And I will read it from here. I'll write in yellow and then I'll kind of get rid of that. So this, and you don't have to write this right now, it's on the handout. And if you haven't already gotten the handout, maybe the teacher can give you the handout right now. But the sine of an angle is equal to the opposite over hypotenuse. The sine of the angle A is equal to the opposite over the hypotenuse. And those are the sides. And then the cosine of A, let me get rid of some of that. The cosine of the angle is equal to the adjacent side over the hypotenuse, the length of the adjacent side over the length of the hypotenuse. And then the tangent of the angle is equal to the opposite over the adjacent, so that you're aware of that. Then also, just so that I remember to tell you, the sine to the -1, which is read the inverse sine of x, is interpreted as the angle with a sine of x. Be careful because we're used to sometimes thinking that that to the -1 power means 1 over. And it says that right here. The inverse sine of x does not equal 1 over sine x. There's something different to be used when we actually do the 1 over sine. And so it's this inverse function notation that we're using for trigonometry. And so we're either finding the angle if we know the ratio, and that's what that helps us with. And otherwise, if we're just using sine, cosine, and tangent, then we're finding something about that ratio and we know the angle. Then on graphing calculators, and most of the calculators, I think I've checked many of your calculators already as I've been checking calculators, the second functions of sine, cosine, and tangent. And so these are the keys that we'll be using, but the second functions are usually the inverse. So if you push that second button and then sine, you're finding the inverse sine, so you're finding the angle. And then if you use calculated measures, you have to be careful not to round until the last step. And so sometimes if we round too soon, like our angles won't add up to 180 degrees. They might be just a little bit off. So just be aware of that. And it says in the following equation, we don't even know what that was. If you know something like 2 sides are 9 and 5, you want to use the inverse tangent of 9 over 5 as you're working other parts of a problem, and instead of the approximate value. If you forget that, just make sure that you're writing what your approximate values are as you go so that you don't miss anything. And then, of course, this just kind of reiterates that or says that again. When finding missing measures of a triangle, the angles may not add up to 180 degrees because of rounding errors. And so by that they mean, if you're using an answer to find an answer, then sometimes that second answer will be off a little bit as we go. So just be aware of that right now. And we say as a general thing we want to remember, if possible, we don't want to use an answer to find the next answer. Occasionally, we can't avoid that. So that is something that will happen as we go. Now, this is actually where we're going to kind of go through what exactly these trigonometric ratios are. And so then we'll go through this. So these are the trigonometric ratios. And today I will read to you because I'm not here to call on people. So if triangle ABC is a right triangle with acute angle A, then the sine of angle A, written sine A, is the ratio of the length of the opposite leg opposite angle A, OPP for that, to the length of the hypotenuse, HYP. So last week, I think on Friday, we talked about labeling the sides of the triangle. So when I write on this, I'm going to write in yellow because I don't want you to write on it because I'll erase it and kind of go through things. So if we look at this right triangle right here, we should be able to identify that the hypotenuse is C no matter what. And then we talked about this on Friday. If this is angle A right here, this is my angle that I'm talking about. And I'm maybe going to erase all of that again. This is the hypotenuse no matter what. If I trace angle A, the opposite side is not traced, so it's across from or opposite. And then the adjacent side is part of that angle, but it's not the hypotenuse. So this is the adjacent side. It's kind of a part of that. So if we're looking at angle A, the opposite side is that little a. It's very common in trigonometry to name an angle with a capital letter and the side opposite it with the same letter as a lowercase letter. And so you'll see the sine of A is equal to the opposite over the hypotenuse. So the ratio is going to be A over C. So the sine of A is opposite over hypotenuse. Now notice what happens when we move to B. Now the hypotenuse is always that side that is opposite the right angle. Again, if I trace the right angle, the hypotenuse is not traced. And so now though, if I'm talking about angle B and I trace that angle, then the side opposite angle B is little b, where segment AC, and the side adjacent to angle B is part of that angle, but not the hypotenuse, so the adjacent side is here. Notice that now these have flipped the order, that the opposite side and the adjacent side are kind of interchanged, have changed position as we go. So what we want to know for this one is the sine of angle A is the ratio of opposite, and I'm going to say, it says 2, we'll say over hypotenuse. So the sine of angle A is the ratio of opposite to hypotenuse. And that might change based on our picture as we go. Then the next ratio is cosine. And so and of course it is super important that triangle ABC is a right triangle, but that's going to be our expectation. So we're not highlighting that part as we go through this. So I'll read this next one. If triangle ABC is a right triangle with acute angle A, then the cosine of angle A, written COSA, cosine A, is the ratio of the length of the leg adjacent to angle A, ADJ, to the length of the hypotenuse, HYP. So the cosine of angle A is the ratio of adjacent to hypotenuse. So adjacent to hypotenuse. So again, I'll do some tracing in yellow. So if we want the cosine of A, again, the hypotenuse is opposite that right angle. If now I'm talking about angle A, the opposite side is there, the adjacent side is there, and so the ratio for the cosine of A is the adjacent side, which is B, over the hypotenuse, which is C. And we're going to be writing those right away today as just ratios, fractions. Sometimes we'll reduce, sometimes we'll just leave it as is because we're going to go further than that often with problems that we do. So let me get rid of all that again. And again, same thing happens with angle B. And so here, the cosine of angle B. Here's angle B right there. This is the hypotenuse, and this is the adjacent side. Now I'm just talking about the two that we're using. So the cosine of angle B is the ratio of the adjacent, excuse me, over the hypotenuse, or A over C. And so you're going to want to remember these using that SOHCAHTOA idea, and we'll talk about that after we look at this last one, which is the tangent. I will slide that up a little bit just so I can see it a little better. And so I'll read this one. If triangle ABC is a right triangle with acute angle A, then the tangent of angle A, written tan A, is the ratio of the length of the leg opposite angle A, OPP, to the length of the leg adjacent to angle A, ADJ. So tangent of angle A is the ratio of opposite to adjacent. And so that's how we're going to kind of remember those as we go. Now, I will have you write on this handout on the triangle and some of these other things. So the big thing is, go ahead and on that picture label the hypotenuse, C as the hypotenuse, little c. And a lot of times now I'll say little c or big C or little a or big A. Little letters indicate the length of a side. Capital letters indicate the angle as we go. So what I'd like you to just do is circle this little piece of that. So sine A is OPP over HYP, and that's the SO of SOHCAHTOA, S-O-H. And sine is opposite over hypotenuse. And it is the sine of the angle. You don't want to forget that, because sometimes people forget where to put that angle in as we go. And so that's SO. Ka is C-A-H. And that, if you would circle this little piece, that's the cosine of the angle is equal to the adjacent over hypotenuse. And then finally, TOA, T-O-A, is, and take a minute and circle one of these. So that's the tangent of the angle is equal to the opposite over the adjacent. And so that SOHCAHTOA mnemonic device can really help you know what trig ratios are which ones that you need to be doing as you go through. We're going to focus on this part of the slide today in class, and then later we'll do these inverse trigonometric ratios. We will go through this piece of the handout before we move on. So these are the inverse trigonometric ratios, and we'll write ourselves a little note. Use to find missing angle. So we're going to use these to find the missing angle. And I will read these. So if angle A is an acute angle and the sine of angle A is x, then the inverse sine of x is the measure of angle A. And in symbols is where we're going to do our highlighting. If sine A equals x, then inverse sine of x equals the measure of angle A. So here's what we're gonna underline pretty much that whole thing. If sine A equals x, then inverse sine x equals the measure of angle A. And so that x is going to be that trigonometric ratio. It might be written as a decimal. It might be written as a fraction. We're not sure. And then the others are the other trig words that we're going to use. If angle A is an acute angle and the cosine of A is x, then the inverse cosine of x is the measure of angle A. So if cosine A equals x, then the inverse cosine of x is equal to the measure of angle A. And then this last one is about the inverse tangent. If angle A is an acute angle and the tangent of A is x, then the inverse tangent of x is the measure of angle A. And so if A equals x, then the inverse tangent of x equals the measure of angle A. And again, we won't emphasize these bottom part of this handout right now, but we will be doing that in this lesson. And so let's maybe go up, way back up here, and where it says trigonometric ratios, let's maybe write something like we wrote down there. So used to find lengths of sides. And just keep in mind, we still know the Pythagorean theorem. That was in this section. We kind of focused on that even though we've used it all year. And we still can find a missing side sometimes using the Pythagorean theorem. Now, my next slide is a sentence frame about learning SOHCAHTOA, and we'll do that maybe tomorrow when I'm here. And it is, the way it'll work is I'll point to this piece, and then I'll call on you, and you'll say things like the sine of an angle is the ratio of opposite over hypotenuse. So you'll fill in the blank just by reading this. You won't be writing it as we go. And then likewise, I'll just highlight this. I won't write the words. The cosine of an angle is the ratio of adjacent over hypotenuse. And we'll go through that. And then the last one is the tangent of an angle is the ratio of opposite over adjacent, excuse me, as we go. So now I want you to look at this and notice that we have the the lengths of all three sides, 12, 35, and 37. Keep in mind that if we didn't have one of those sides, we could get the missing side using the Pythagorean theorem. So I'll just pretend a minute. You don't have to write any of this down. So I should write in yellow. That's my favorite don't write this down color. So if I didn't know this, I would find it by taking the square root of 12 squared plus 35 squared, and that should either be 37 or very close. And then if I didn't know this side, I would take the square root of 37 squared minus 12 squared. If I was here, I would ask someone, why do we subtract in that one? And so kind of think about that a moment. And the reason we subtract in that one is because when we know the hypotenuse and we're finding a leg, the hypotenuse is always the longest, so we use the version of the Pythagorean theorem where we subtract. And likewise, if I had to find this one, it would be the square root of 37 squared minus 35 squared, and hopefully that's 12 or close thereabouts. So our job is to express a bunch of trig functions as a fraction and as a decimal to the nearest hundredth. And so I will go through these and then we'll kind of get started on a worksheet. So I have to pause myself because I'm not looking at the handout, and I do want to be doing that. So for this one, I just gave you that picture. Maybe I didn't give you a super amount of space there. So you might have to write some things on your notebook next to the handout for this problem number 1. And on your notebook paper or wherever you're going to be able to see it, write again, SOHCAHTOA. And let's just kind of go through these. So it says express the sine of L as a fraction and as a decimal. And so we're going to write down sine L equals, and sine is opposite of the angle is opposite over hypotenuse, so that's what we're going to use. And so the sine of L equals OPP over HYP, just as a reminder to ourselves. And so when we look at this, here's angle L, and I'll trace it in yellow. Angle L is right here, and so the hypotenuse is always the hypotenuse. The opposite side is that 12. So when we look at that, the sine of L is equal to the opposite side, which is 12, over the hypotenuse, which is 37. And it says to give it to, or to write that answer as a fraction and as a decimal to the nearest hundredth. So take your calculator right now, 12 divided by 37, and we'll write or, and you can fill in the blank with that number. And you should have gotten 0.32. Now, excuse me. We are going to do a bunch of others. And look, I'm just going to show you. I have different slides for every one of these. We're just going to find all of those different things. And I'm just going to use this very first slide to answer all of these. So our next part is to find the cosine of L. So we'll write cosine L. And maybe I should have maybe done this right at the beginning, but I'll label this as the hypotenuse because that is the hypotenuse no matter what. And I'll redraw that in yellow because I'm going to erase it. So this is the cosine of angle L, and I'm just reminding myself the opposite side is that 12, and the adjacent side is that 35 length. And so the cosine of L, if I look right here, cosine is of the angle is adjacent over hypotenuse. And so I'll just write myself ADJ over HYP. And this definitely is probably not fitting in the space that I gave you. So for that, I apologize. And adjacent over hypotenuse, so the adjacent side, if I've got my triangle labeled for myself, and I caution you a little bit on that because we'll also use angle N, but the adjacent now is 35 over the hypotenuse, which is 37, or find that as a decimal to 2 decimal places. And you should have gotten 0.95. Then the last one for angle L is the tangent of L is equal to, and when we look right here, tangent is opposite over adjacent, so we will write OPP over ADJ, opposite over adjacent, and sometimes I just have to get rid of things that way. And so then in this way that this is configured, the opposite side is 12. The adjacent side is 35. So 12 over 35, or get that as a decimal to the nearest hundredth, 2 decimal places, just a reminder, is 0.34. And sometimes we put a 0 in front of those, which is a good habit, and I did not do that. So then there's 3 more answers that we have to give. And so again, this is probably not fitting on that space that I gave you on that picture. And so for these, now we're going to look at angle N. So from angle N, the hypotenuse stays the hypotenuse, so that I don't have to do anything with. If I trace now angle N, notice that my opposite side is now 35, and my adjacent side is 12 as we look at that. And then we'll write all of these same trig functions. So first we'll do the sine of capital N. And the sine of the angle is the opposite over the hypotenuse. And so the sine of N is equal to 35 over 37. Or, and if you look carefully on your paper, you have that as a decimal already. 35 over 37 is 0.95. And then the next one is the cosine of capital N. And the cosine is the adjacent over hypotenuse. And so the adjacent side, excuse me, is 12, and the hypotenuse is 37. And so that one is 0.32. And then finally, we're going to find the tangent of N, T-A-N, capital N. And the tangent of the angle is the opposite over the adjacent. So for this one, the opposite side is 35, and the adjacent side is 12. Notice that is not an answer from before, so take a minute and Oh, I should have written or for this one. My apologies. And take a minute and get that as a decimal. And you should have gotten 2.92. Kind of look over those and see if you can, make some observations about things. And tomorrow we might write a little bit about that, or what you think is true about those ratios as we go through that. Now, the next thing, and we kind of did all those on one paper. And the next thing we're going to do is work on the worksheet sine, cosine, tangent. And excuse me, essentially it's this same process, but maybe finding a missing side using the Pythagorean theorem. If you haven't already got it, maybe pause this and make sure everybody gets this worksheet. It should say a little 2 on it, sine, cosine, tangent, because I think on Friday you got the one that is called something like labeling the sides of the triangle. So, I think I have the wrong, there. And I want to use the side that says 1, number 1. And so take a minute, just write on there someplace, SOHCAHTOA. And it says, find the missing side of each right triangle to the nearest tenth. Write each trig ratio as a fraction. No need to simplify fractional answers. And so take a minute, and the very first thing you want to do is find the missing side using the Pythagorean theorem. And I'll give you a moment to do that. So if you've taken a moment to do that, you should have gotten that AC is equal to 6. And so I will show some work here as well. 10 squared, AC is equal to the square root of 10 squared minus 8 squared. And that is, since we're rounding, we don't have to put things in simple radical form. In this case, though, it turns out to be the whole number 6. And then we're going to look at the ratios for each of these. And we're writing each trig ratio as a fraction, and there's no need for us to simplify our fractional answers. We really just want to practice kind of writing all this down. So in this first one, for this problem, let's label the hypotenuse because it's always going to be the hypotenuse. And then hopefully you can see your SOHCAHTOA. Maybe I'll write it here again. SOHCAHTOA. And so for the first couple, and notice they kind of mix up the A's and B's. So the sine of A is equal to the opposite over the hypotenuse. And so if in my mind I kind of trace that A, the opposite side is A. And so I'm going to get rid of my tracing though. This opposite side is 8, and the hypotenuse is 10. So the sine of A is 8 over 10. And let me go back up here a second. And yes, that's all we're going to do is write it as a fraction. And then the next one is the cosine of A. So again, in my head, I trace that A. The cosine of the angle is equal to the adjacent over hypotenuse. So the adjacent side here is 6. The hypotenuse is still 10. Now it asks about the sine of B. So in my mind, I trace this angle B. So there's angle B. So now the opposite side is over here from B, and the adjacent side is right there. So I just kind of have that in my head. I don't really want to have it on my paper as I look at this. So the sine of the angle is opposite over hypotenuse, and so from angle B, that is going to be 6 over 10 again. And then the cosine of the angle is the adjacent over the hypotenuse. So the cosine of B is adjacent, which is 8, over hypotenuse, which is 10. And then it asks us for tangents of each of those. So notice I have to go back to angle A, and the tangent of the angle is the opposite over the adjacent. So in this one, let me get rid of that little marking. In this one, I'm back to looking at angle A, and the tangent of the angle is opposite over adjacent. Here now, the opposite is there at 8. The adjacent is that 6. So let me get rid of all that. The tangent of the angle is the opposite over the adjacent. So that's going to be 8 over 6. And the last one is the tangent of angle B. So I've got that back in there. The tangent is the opposite, which is 6 this time, over the adjacent, which is 8. And so that one is 6 over 8. So your job now is to just finish this and this worksheet if you can during class today, and it won't be due until this set of worksheets is due, but this is your class time to work on it. So make sure in this next one, notice the hypotenuse is that 22. I would suggest that you label the hypotenuse so that when you find BC on that one, you're going to do the square root of 22 squared minus 19 squared. Remember the directions say to find the missing side first, round that to the nearest tenth, and then write each trig ratio as a fraction. No need to simplify fractional answers at this point. And I will see you tomorrow.